Hello everyone and welcome to the variables lecture for CIS 115 or CSC 120. We're still in week 3 of the class and I'm still coming to you from the nose of the B-17, 70-year-old World War II bomber that I took a flight in at the Salisbury airport. So I'll switch over to the actual page where I can share my desktop with you. Okay, so you should be seeing my desktop now. We'll double check that, and it looks like it's going. So the variables lecture, a variable in Python is just a spot of memory that we give a name to. Now, there are some links here to your textbook, and if I click on the first one where it talks about basic variables, you can see right here number of dog's teeth is a variable name that they're talking about. It can just be a single letter. Variable names do not have quotes around them. You remember in the literals lecture, a string literal would have double quotes or single quotes around it. And remember, with string literals, if you started with double quotes, you had to finish with double quotes. If you started with a single quote, you had to finish with a single quote. Well, the names of variables do not have quotes around them. Some of the other rules for naming variables, and I think they get to it here in this material in your textbook. It's also in the lecture as well, but the named spot in memory that we're setting up, there's some rules that you have to adhere to when you're naming variables. And they're pretty simple in Python. The name of a variable must begin with either an underscore or a letter. You heard me say that right. An underscore and a letter. So if here we are, and if I wanted to name a variable, this would be a valid name. Okay, underscore a variable. Okay, also this would be a valid name, a underscore variable. Okay, now variable names are case sensitive. That means that a variable and a variable like this, as far as Python's concerned, these are two different variables because one of them has a capital A in it, the other one has a little a. So variable names are case sensitive. And so that will probably come back to bite you at some point. You may start using a variable like this and then get messed up and refer to it like that in your code, and this is definitely not the same as this. So we said that they had to begin the rules for the names. Must begin with a letter or an underscore. And this is the underscore, that character right there. Okay. They cannot start with a number, so that is not going to be if I named a variable or tried to name a variable this, that's not a valid variable name because it starts with a number. Okay? They cannot have any embedded spaces in them. So this would not be a valid variable name. You notice I put a space between there. Python would consider this to be a variable and this to be a variable. So another thing or rule for a variable name is they cannot be a Python keyword. So some examples of Python keywords are, if you look at the lecture, def. If you watched the lecture that we had for literals, then you know that def is the way we started a function. That's the way we told Python, hey, we're going to be creating a function. Def is the key word. Global is a keyword. If is a keyword in Python. Else is a keyword. ELIF is a keyword. That's short for else if. And we already talked about and in the literals lecture. Or we talked about or in the literals lecture. And return is a keyword. And you may have seen return when we were working in the literals lecture. I don't have a return here in this one, but right here, notice that it has return there. Return says send this back from our function and make the name of the function here have that value. So we'll talk more about functions here in a moment, but you notice the rule, no keyword can be used as a variable name. So we've got the rules kind of set out here. Number one, they must begin with a letter or an underscore. Number two, they cannot start with a number, okay, and cannot have any embedded spaces, okay, and number four, they cannot be a Python keyword. Now, if you wanted to get the whole list of keywords in Python, there are not that many, and you may remember that Python or Tawny changes things, I think, that are keywords. I think it changes them to the color purple. So I'm going to switch back to Tawny, start a new program, and paste this in. So here's the code that I have right now in Tawny. Let's see if I can make this bigger for you. And make sure that we're still recording. Yeah, we're still going. Let's see if I can make this bigger. Yeah, that's making it a little bit bigger. Okay, so if you import the keyword library and then print keyword.kwlist, then you can get Tawny to print out every single keyword in Python. So here goes. I'll call this keyword demo.py. Look at all the keywords that came out. False, none, true, and, as, assert. So there's actually not that many keywords in Python, and that's nice because that means everything else could be used as a variable name, right? Now, you may remember I told you that it changes keywords to a different color. So if I did this, print true and true, did you see how it changed the literal true, the keyword and the literal true? It changed those to all purple. That's because they are keywords here. They're keywords. So one thing also to keep in mind, if we tried to set and equals 2, watch Python below. You see what it says? Invalid syntax. That's because and is a keyword, and we just got done saying you can't assign anything to and because it means something special in Python. But, and word to the wise, don't do what I'm fixing to do. But if we did this, notice it's not changing it to purple. We could use this as a keyword. Why am I able to get away with that as a keyword? Well, the reason is I made the A capitals, and capital A, little n, and D is not a keyword in Python. Remember, a little a and d is. So there might be some tricky questions on your homework. Make sure you don't fall into that trap if it's asking you something like, which of the following is not a valid variable name? Well, this would be okay as a variable name. Same way that we couldn't do this. You notice how that's purple. This is a keyword in Python. But if I did this, I could get away with that. You see that runs fine. Okay? And I could come down here and print, and it will be fine with that. You see the 2 printing out? Okay? That's because I capitalized it. Remember, variable names are case sensitive. So are keywords in Python. So, functions and variables. Okay? Remember that function names are variables too. Function names are variables too. And that includes the functions that are built into Python, like the print function. Print is actually a variable name. It is a variable that points to the code to cause something to print in Python. And like I showed you in the literals lecture, we could erase the print code if we assign something to print. Now this is just a simple little program here to print hello and your name. So let's do that just so you can see it work here. Start a new program up, paste that in, okay? Clear this out, and we'll save this as variable demo. Alright, so we're printing a 5. We're assigning Michael Raines to name. Remember, the equal sign is what takes whatever is on the right of the equal and it stuffs it into whatever's on the left. So the equal is the assignment operator. So when this runs, it should print a 5, and then it should print hello Michael Raines. So let's see if that works. And you can see it does. Okay? So that works out fine. It tells you right here that name is a variable. Okay? And now let's go mess something up here. Let's overwrite the code to print in Python. So right here, I'm going to do this. Print equals 9. So what we just did with this line is we reassigned, we got rid of all the code that lets us print from Python, and now the name print, instead of having that code to cause something to print, is actually just going to have a 9 in it. And you saw how when this worked before, it said hello Michael Rains. Now you can see that it says an int object is not callable. That's because we made print into an integer variable that had an integer 9 in it. And so now when we're trying to call print hello name, it is, instead of having the print code, it's actually an integer, and we can't call an integer. Remember from the literals lecture, the way we called a function was by putting the name of the function with the parentheses on the end of it. So let's talk a little bit more about functions and function signatures. Now here's a fairly simple little program. First, let's just write a function to square a number. Okay. Now I'll start out real simple with this and then get more complicated as time goes by. So I'll start a new program up. Remember, if we wanted to create a function, we do def. Okay? And then we give it the name of the function. Okay? And if we weren't going to send anything into it, I think about whatever goes inside these parentheses right here as the door into the function. So if we weren't going to send anything to the square function, then we could do this. Return 5 times 5. Okay? And then if I did this, print, okay, remember the print, and I said square, okay, this line calls the square function. These two lines up here define the square function. Remember, lines that start with a pound are just ignored by Python. Those are comments. Okay, so when I run this, I'll have to save it first. When I run this, you see it prints 25 out. So let's talk about what's happening here in this program. Here we told Python that we were going to give some code a name. Okay, so this line is called the function signature, the line that says def, square, and the parentheses. And then notice it has a semicolon on the end of it. This line tells Python to, hey, I'm going to give you some code, and I want you to give it the name square. So this last line right here that says return 5 times 5 says, okay, when this code right here runs, okay, I want you to make the name square have the value of 5 times 5. So when we ran this line right here that says print square, it says, okay, I want you to go find the code that's named square and run it. Okay, the code then returns 5 times 5, so the name square with the parentheses on it actually has whatever we told it to return as that value, and that's why 25 prints out. What happens if you forget to put the parentheses on the end of the square function name? If you forget to put the parentheses on the end of it. Instead of calling the function, Python's just going to tell you where it put that function in memory. So it's gonna, what would print out down here when this code runs is it would say square function at some memory location. Let's just do it. You see what it said on my computer? Function square at 0x7f62c. You notice what this is, anybody? That's hexadecimal. That's hexadecimal. It's actually telling us the memory location in the number base hexadecimal, base 16. Okay, so if you ever see this coming out when you ran your program, you forgot to put the parentheses on the end of the function that you're calling. So Python is just telling you where that function is in memory. Okay? So you can see this is not particularly useful right now, is it? Because all this is ever going to do is return the square of 5. But if we wanted to set it where you could pass something to it, then we could put something inside these parentheses on our function signature. Remember, this line is the function signature. Okay? So this top line right here is the function signature. This num is what we call a formal parameter. When Python sees this, it says, oh, you want to create a variable named num, so this has to meet all the rules for a valid variable name. And when somebody calls this square function, I'm going to require them to send me something so that I can put it into num. So right now, if I tried to run this code, Python would throw an error and it would actually tell us that we're trying to call the function, but we're missing one argument to it. So what did it say when I tried to run it? Square is missing one required positional argument named num. Okay? So in order to fix this, I could do this. Num times num. Okay? And then, now that I have written this code to use this num variable, okay, I can actually then pass anything I want to it, like 2, and you can see when it runs I get 4. If I passed a 5 to it, you could see now that it gives me a 25. So we're able to use this function to do lots of different squarings rather than just 5 times 5 by changing what we send to it. So back to this code right here. Okay, I'll paste that in to Tani so we can talk some more about it. Okay, so here's the code from the variables lecture that I passed in. This line is the function signature. Here we're creating a variable named SQR, and we're actually using the exponents operator. Remember, 2 asterisks together like that says raise this variable number to the 2nd power. And then this line says make the name square have the value of whatever this variable SQR has in it. So here we created another function named main. This function named main does not take any parameters in, okay? But it's doing several things. It's printing the square of 2, it's printing the square of 5, it's printing the square of 100, and then it's returning. Now, this line is what causes the whole program to run. Python is an interpreted language. Interpreted. That means that it reads the language, the Python interpreter reads the language one line at a time, and it translates it and runs it. So it's kind of like the person at the United Nations that sitting next to the whatever ambassador, and they have headphones on and they're listening to whoever's talking, and each time that person says a word, the interpreter is changing that word into a language that that ambassador next to him understands. So this language is running one line at a time. So if I leave this line that says main with the parentheses on the end of it off, and I try to run this, you will notice that nothing happens. You see, nothing came out. I guarantee you'll make that mistake at some point. All we've done is created two functions. We've created two sets of code here, and we've told Python to give this code a name, but we never told it to run. We never told Python to run it. And also, you remember I told you that Python was interpreted. So if we tried to do this, okay, I'm telling Python to go run some code named main, but Python is reading this program from top to bottom, and when it's right here, it doesn't know about main. It's kind of like you're reading this book and you don't know how it ends. Okay, so Python at this point on the first line in the program, it has never seen the code for main, and so it's going to blow if I try to do this. You see what it says? Name main is not defined. So if you want to be able to run it, you have to call it after it knows what that code is. So that's why the function call right here, this line calls the main function, causing it to run. Okay? So this has to be done after Python knows what main is. So now when we run this code, you'll see that it works. Okay, let's talk about what the code did. Here it created the square function and put it in memory somewhere. Here it created a main function and put it in memory somewhere. And here we told it go run main. So when Python sees this line right here, it jumps up here and it does all the code inside of main. So what did main do? Main called the square function. So inside this main function, when it hits this line right here, Python jumps up here and it does everything in square. So here we passed a 2 to it. So 2 got assigned to number. Number, or 2, to the second power is 4. So 4 was assigned to SQR, this variable named SQR. And here we told Python to give the value of SQR, which is 4, to the name square. And so that's why this right here printed out a 4. The same way here, when it gets down to this line, it says, okay, send a 5 to the function call for square. So number gets a 5 assigned to it. 5 squared is 25. Assign it to square, SQR. And then here it says give the name square the value of whatever's in this variable SQR. And so that's where the 25 came from. Anytime you put a return in the function, notice this return does not return anything. That just tells Python that anytime you see the name or the keyword return, that's the end of this function. We're leaving main and we're going to come back right here in our program. So return is usually the last thing that you see in a function. And even if return is not the last thing, whenever Python is going through the code for the function and it encounters a return, it is over when it sees return. It's coming back right here. So we've already talked about what a function signature is, okay? And here is a function to raise a number to a power. Now this function has got two formal parameters. The one is called number, the other is called power. Okay? So it's got an if statement in here. We'll talk more about if statements in a later module of the class. But an if statement causes Python to make some kind of decision. This is where you can make your program start thinking rather than just using the computer like a big calculator. Here, our program is actually thinking. Okay? So if I copy this code and put it into another program, here I'll start a new program up. Okay? Remember when we were talking about functions, everything that's indented is part of the function. When you outdent, you are no longer in the function. Python lives off of the indentation here. So indentation is real important in Python. If you start indenting with a tab, you have to keep indenting with a tab. If you start indenting with 3 spaces, you have to keep indenting with 3 spaces. If you paste code from the internet into a program, you've got to keep using whatever they were using to space it over for the indentation. So I pasted this code out of the variables lecture into Tawny. So I'll have to keep using whatever they were using. Now when I outdent, I'm no longer in the power function anymore. So if I wanted to test this function out, I could do that. If I wanted to raise 3 to the 3rd power, okay, I would do this. Power. Okay. So this 3 is going into number. This 3 is going into power. And so when this function right here runs, it's going to take whatever number came in, okay, and check to see if it's equal to 0. Any number to the 0 power is the number 1. It doesn't matter if it's 16 to the 0 power, it's still a 1, okay? Otherwise, if it's not a 1, then take whatever the number was and raise it to, it's calling itself right here. It's calling itself again. Raise it to the number with the power -1. So there's a whole lot going on in this function. Let's see if what 3 to the 3rd power should be a 9. So let's see if this function is going to return a 9 to us. Power function demo.py. Okay. It's looks like it's got a problem here, doesn't it? Why? Have you spotted it? Right here, it's POWER. It says that the error is right here on this line, print power 3 to the third power. Okay, so this is actually got an error in it because it's overriding the name of our function inside the function. So we would need to change this variable name to something else, like this. Now let's see if it works. Let me clear it and run it again. Okay, it's not blowing now. It's just not really doing what we wanted to do, is it? It says maximum recursion depth reached. Okay, so this is trying to call itself over and over and over. So could we fix this? We could. We could fix this whole thing by just doing this number asterisk asterisk power parm. Okay, now that should fix the whole function. By the way, a function can call itself. You saw me do that. But 3 to the third power should be 27. So 3 times 3 is 9. 9 times 3 is 27. So we just fix that function that's in this lecture. Okay. So remember, when we get to the homework, you're going to have to count the number of variables that are present in some of the questions. So I'm going to pop into the homework for Module 2 and let you see if you can follow how I'm working a few of these homework questions. Now, odds are you will get some of these homework questions, and but everybody gets a little bit different homework. But odds are you're going to get some of what I have here. So we already did this question 2 in the literals lecture. Let's look at question 3 here. Question 3 says, true or false, is this code legal? Def print high there, print high equals 4, and then print high. Well, easiest way to tell if this code is legal or not is to copy it and paste it into Tawny. So if I start myself a new Tawny window up and I save that as, let's just call it homework test.py. Okay, and then let's run it and see what happens. Is it legal? It is. What are they doing here? Remember, you can, if your function only has one line in it, you can put that one line right here. This is all that's part of the print high function. This, what we have right here on this line, is actually equivalent to this code. Okay? So here we told Python, hey, Python, we want to create a function named print high. We want to give some code the name print high, and we want that code to be print high there. But then we overwrote the code in our function. We said, nope, I don't want you to have this code for print high. I want print high to be the number 4. And so here we printed the number 4, and that's why the 4 came out. So while that code is legal, it's not real easy to understand, but you saw how I checked it. Okay? Now we said in the literals lecture that the equal sign is an assignment operator. So remember, the equal sign takes whatever is on the right of the equal and it figures out what that is, and then it stuffs it into whatever's on the left hand side over here. So this is going to assign the square of x into x. So let's see what the question says. Which of the following expressions squares the value of the variable x and stores the resulting value back into x? So this says x squared and put it back into x. Well, that sounds good to me unless we find something better. This is saying multiply x times 2 and put the value back into x. This is saying this is not an assignment at all. X asterisk asterisk 2 says square the value that's in x, but don't do anything with it. And this is taking x and multiplying it times 1 divided by 0.5. So this is not raising x. This is actually multiplying x times 1 divided by 0.5. So that's not going to square it. So yes, this is the correct one. Let's talk about a swap. Let's talk about a swap of variables. So right here, my question number 5 says, true or false, this code correctly swaps the values of A and B. We could check this out by just taking the code and copying it to the clipboard and pasting it into Tawny. But if we do that, if we do this right here, we've got to add something to it. We've got to add something to it. So if you wanted to know if this code was correctly swapping A and B, you would have to give A and B some values and then print them out. So I'm going to give A the value of 100, and I'm going to give B the value of 1. Okay? And then after this code runs, I'm going to print out A is, and a comma, and then A. So what's this line doing? This line says print out the string literal A is, and then by putting a comma here, I can mix two things in my print. So the comma is going to print a space, and then it's going to print the value of A. So then I can say print B is, and then a comma, and print B out. So you saw up here, A had 100 in it, B has 1. Let's see if when this prints, it should, if it's correctly swapping them, A should have 1 in it, and B should have 100. So what did I get when I ran it? I got A is 100, B is 100. So the answer is false. This is not correctly swapping the values. Okay? Could we rewrite this so that it was correctly swapping the values? Yes, and let's do that so that you understand. If you need to swap two things, the steps are, I'm going to put some comments in here first. First, I'll write it out. First, save the value of the variable you want to swap. Okay? Second, change the variable you just saved. And then lastly, change the variable, change the other variable. Okay, so that's my plan right here. So I'm going to save A into temp. So temp equals A. I just did this line right here. Next, I'm going to change A equals B. Second, change the variable you just saved. I had just saved A, so now I'm changing it. And then third, it says change the other variable. The other variable is B, so B equals temp. So I just did my steps here, right here. I just did those. I was going to change A, so I saved A. Okay? And then I set A equals B, and then I set B equal to the saved value that I had here of A. So when I run this, now A is 1 and B is 100. They are swapped. So that's the right way to swap two variables. What's the output of the following code? Well, that's easy enough. Just take the code, copy it, come back up here, and paste it into Tawny and run it. And you can see what's the output of this code. What did I get when I ran it? Strings not callable. No output, an error occurs. Okay? How could you work this question? My question 7. What's the value of Y after this code fragment is executed? Again, you can use Tawny to your advantage right here. All you got to do is paste the code in to Tawny and run it. Except it says, what is the value of Y after this code is executed? Well, all you've got to do is do this, print. I'm just printing a string literal so that it makes sense to you. They want to know what's the value of Y after this code is run. So this is going to print out the string literal, the value of Y is, and then whatever's in Y. So when I run this, the value of Y is 4. So that's the way I work that question. Which of the following is not a literal? Is 7 a literal? Yeah, 7 is an integer literal. 3.2E1, is that a valid literal? Well, all you've got to do is try to print it. If it's a valid literal, it will Python will be okay with it. So right here, if I do this, okay, put it inside a print. If something prints out, then we're good to go. You see, that is 32.0, so that's okay. Is awesome a valid literal? It is. That's a string literal. What is literal right here? That's a variable name. So if it asks which of the following is not a literal, then this would be a variable because it meets all the rules for a variable name in Python. So, okay, let's go down and see if we can find one that's asking us, yeah, right here. How many variables are defined in this code? Now remember, you have to always watch what word is being used right here, because this word changes everything. If they had said how many values are present in the code, you'd have a different answer from how many are defined. Defined means how many variables were created in this code. So I'm going to copy that and I'm going to paste it into Tani so we can talk about it. Okay, here's the question. I'm just to make this valid Python code, I'm going to put that as a comment. How many variables are defined in this code? Well, here, this line right here does what? It defines a variable named greeting. It assigns the string literal hi there into, that's the assignment operator, equals. It assigns it into greeting. So greeting is 1. Okay, so variables defined. Greeting. What else? Def show. What is this line? This line is the definition of a function. Okay, and remember, I told you that we could rewrite that function like this. This is the way most people are accustomed to seeing the function. But this, because it's indented, this line right here is part of the show function. So this is saying Python, create a variable named show and assign this code to it. So we've got show is the name of a function and it is defined. What are me and last? Me and last are formal parameters, and that tells Python to create a variable named me, create a variable named last, okay, and take whatever is being passed in right here and plug it. Sally's getting plugged into me. Poe is getting plugged into last. So we've got 2 more variables, me and last, that were defined. That means being created. Is print a variable name? Yes, print is a variable name, but print is defined with Python. It's not defined in this code. So print, while print is a variable name, it is not defined in this code. So we have 4 variables that are defined. Okay, we've got 4. Where did they come from? 1 is greeting, 2, 3, and 4. Now just to show you, if they changed this word to be present, now we'll go ahead and answer the homework question there so that I don't mess that up. But if they had asked this question this way, instead of saying how many variables are defined, if they had said present, then the number would actually be 5, because it would be greeting, show, me, last, and print is also a variable. It's the variable containing the code to print in Python. So that would have changed, that just changing this one word changed the number that we give there. So you can see that there are lots of questions like that. Make sure that you key off of what word they're using here, whether it says defined or present, because that changes things. Also remember that the names of functions are variables. And remember that the built-in functions in Python are variables too. Okay? But we don't define print. Print is actually something that came with Python. So that's why the answer is different in this one, whether they ask it as defined or present. Well, good luck with the homework for Module 2. Make sure that you understand the difference. Make sure between a defined and present question here. Make sure that you understand that formal parameters are things that are passed into a function. Okay, they are variables. This is the function signature here for a function named show. Everything that's indented, as long as we stay indented, the code is part of the show function. When we outdent, we're no longer in the show function. Python lives off of indentation. This line is the function call. This line is calling the show function, and it's sending Sally as a argument. Down here on this line, what we put in the parentheses are called arguments. Up here, what's inside the parentheses on the function signature, this line is the function signature. What's inside the parentheses are formal parameters. So up here in the signature, me and last are formal parameters. Sally and Poe are things that are getting sent to the show function. All right, good luck.